Alrighty guys, we're going to talk about what causes the seasons, so the reasons for the seasons. So we know we have 4 seasons. We have your winter, we have spring where all the beautiful flowers come out and everything starts to bloom. We have the summer where it's really, really hot. And then we have the fall where all of the plants kind of start to go into hibernation and all their leaves fall off and it's really pretty, but it's definitely starting to get cooler. So the sun. We all know that the sun is the nearest star to the earth, and what you may not know is that it has a diameter that is 100 times greater than the earth's. That means you could take the earth and make 100 copies of the earth and line all 100 copies up side by side, and they would go from end to end of the sun. Like the sun is that big. The sun's core, so inside of the sun, reaches over 15 million degrees Celsius, and the surface reaches 5,500 degrees Celsius. It is a huge, immense amount of energy. And if you remember, we talked about stars, and during their main sequence, they do this thing called nuclear fusion. Nuclear fusion is where they take atoms and they smash them together, and that produces energy. And the energy is released, a lot of it, by temperature, and that's why the sun is so hot. And some of it is also released through light. So a small part of this energy, this light and thermal energy, heat energy, reaches the earth. So the reasons for the seasons. So there are 2 main reasons, and we're going to talk about both. The first is Earth's motion around the sun, which we'll talk about next. And the second one we'll talk about is the tilt of Earth's rotational axis, 23.5 degrees. So Earth's motion around the sun. Obviously we know Earth orbits around the sun. We've been talking about orbits and how they travel in a pathway of an ellipses, and we talked about Earth and how it's nearly a circle, meaning the foci of the ellipses are so close together that it would essentially be a circle. Earth does not really get any further or any closer to the sun. I mean, it does, but not enough where it would make a difference. And the Earth travels around the sun one time, so it goes from here around the sun all the way back to the same place, one time every 365.24 days. You see that 0.24? That's the reason we have the leap years. So every 4 years we have to add an extra day, because technically every 4 years we get an extra day. So that is due to the sun's gravitational pull. So the word revolve. So when I say that the Earth revolves around the sun, that means when one object moves around another object. So one object is the sun, the Earth moves around the sun, so it revolves around the sun. Earth's motion around the sun. So there's really no good place for me to be. Okay. As Earth revolves around the sun, it rotates or it spins on its rotational axis, or an imaginary line on which the Earth rotates. So I'm going to move again. Here's Earth. The Earth is actually not sitting up and down like this. This is in the North Pole and this is in the South Pole. Instead, Earth is tilted 23.5 degrees. This is the North Pole and this is the South Pole. On here, here's the North Pole, here's the South Pole. Okay, it is tilted, so it's not exactly perfect. And this is on an axis, or an imaginary line, that goes from the North Pole to the South Pole. Obviously, it is not a real line or a real pole that goes through the Earth, but there is definitely a line that goes from the North to the South Pole, and that is tilted 23.5 degrees. So the Earth rotates. You know that it means it spins. Okay, it spins on this axis, so the Earth goes round and round and round on this axis, and the rotational axis is just the imaginary line that we just talked about, that goes from the North to the South Poles. All right, so we know the Earth travels around the sun in an ellipses, okay? So, or an ellipse, excuse me, or an elongated circle. Because the sun is not centered in the ellipse, the distance between the sun and the Earth changes during the year. However, the change in distance is not very large. This is what I was saying earlier, meaning we really don't get too much further or too much closer to the sun where it would really make a difference in our seasons, or what we would expect to see. So the Earth's motion around the sun, or how close we are to the sun, is not the reason for the seasons. No, no, no. The reason for the seasons is not that Earth gets closer to the sun or further away from the sun. That does not happen. The second thing that causes it is the tilt of the Earth's rotational axis. So as I said before, we've got the Earth, we've got it on this imaginary line, okay? And as it revolves around the sun, it rotates on this axis, and basically what happens is that during some times of the year, during some points of its rotation around the sun, certain parts of the Earth are tilted towards the sun, meaning they get more light, more thermal energy, and at certain times they're tilted away from the sun, meaning they get less light, less thermal energy, and so therefore it would be colder at that time. So the hemisphere that's tilted towards the sun receives more hours of daylight than the hemisphere that's tilted away. So that's why in the summer the days get longer, and in the winter the days get shorter. So when we're tilted towards the sun, our days are long. When we're tilted away from the sun, our days are short. Earth's tilt causes the sun's radiation to strike the hemispheres at different angles. So basically, in the summer, we get direct sunlight. We get a huge amount of sun's rays that are hitting us. And in the winter, they're a lot more kind of reflected a lot more because of the way we're oriented towards the sun. And I'll show you a little diagram if this is hard for you to picture. The hemisphere tilted towards the sun receives more total sunlight than the hemisphere tilted away from the sun. Thus, the one tilted towards the sun is in summer and the one tilted away is in winter. So here's our little example. So notice how the Earth does not tilt back and forth. It doesn't do one of these, okay? The tilt stays the same the entire time. So you'll notice, here's our thing. Here's the northern hemisphere up here, right? Here's the equator. Here's the northern hemisphere, and it is tilted towards the sun. So it's summer in the northern hemisphere. The winter is happening in the southern hemisphere, where almost no light is hitting it. Here, this would be like a fall for us, and then here would be winter. So now we are tilted, here's the northern hemisphere, we're tilted away from the sun, so we're getting less sunlight. But the southern hemisphere is tilted towards the sun, so it's summer down there. This would be our spring, and it would keep going around and around and around. Okay, so as the Earth revolves around the sun, the Earth's tilt towards the sun changes. Not changes like this, but just as it goes around, it's going to hit different areas of the planet. So during parts of the year, the North Pole is towards the sun. That would be when it's summer. So here's the sun. Here's the North Pole tilted, and remember, it's revolving the entire time. Rotating the entire time. And then the sunlight, notice it's not really hitting the southern hemisphere, it's winter down there. During another part of the year, okay, the northern hemisphere is tilted away from the sun. That would be when it's winter in the northern hemisphere, and the bottom part is tilted towards the sun. That's when it is summer down there. So when the North Pole is tilted towards the sun travels higher overhead. So that means it actually goes directly overhead them, and the sun's rays shine down straighter on that part of the Earth. Because of that, well, I guess you could use an analogy where it's like a flashlight pointing down at a piece of paper. When you hold the flashlight straight above the paper, the rays from the flashlight shine straight down or down straighter, so they are more powerful then. Okay? Okay, so when this happens, you're going to get a solstice, a day when the Earth's rotation axis is most toward or away from the sun. So when it's the most toward the sun, you're going to get those direct rays from the flashlight or from the sun, and this would be our summer solstice, which is June 20th or 21st in the northern hemisphere. That's the beginning of our summer season. When we are pointed most away from the sun, meaning when none of those direct sunlight beams are hitting over top of us, that would be the winter solstice, or December 21st or 22nd in the northern hemisphere. So when the North Pole is tilted away from the sun, like we're about to see right here, okay, the sun stays lower, and so the only impact, it will only go across the sun like this. It won't go over the top. So that means the sunlight rays hit it at an angle. And when that happens, it's winter time. So if you point a flashlight at a piece of paper at the angle that the sun would be at, the rays for the flashlight spread out. And when they spread out, that means they lose potency. It isn't as concentrated, and so therefore you get a lot less heat and a lot less thermal energy. So we also have equinoxes. This is the day when the Earth's rotation is leaning along Earth's orbit and is neither toward or away from the sun. That means it's kind of, I don't want to say the rotational axis is still at the same place, but it means it's kind of in its middle. It's either in spring or fall. And the equinox is March 20th or 21st. Essentially, that's the midline, so it's not the shortest day, it's not the longest day, it's somewhere in the middle. And the sun's rays are hitting both the northern and the southern hemisphere at equal intensities. And so that would be March. March is the spring equinox, March 20th to 21st, and the fall equinox is the 22nd and 23rd in the northern hemisphere. All right, so those are the reasons for the seasons. I do want to show you really quickly a little animation. Okay, so here's our sun, here's our Earth. So if I go ahead and push play, okay, you see that we are turning, okay, and here's our person, so this is where we're living. We're in the middle of winter right now, and because we're in the northern hemisphere, here we are, okay, you notice how the sun is not going very high in the sky, not going high at all. So I'm going to go ahead and speed it up. So now we're in spring. Notice how it's starting to go higher in the sky, and we're starting to tilt towards the sun. So it's going higher and higher. So now we're in the summer. We are tilted directly towards the sun at this point, and it is going very high in the sky. Okay, look at the sunlight angle. This is part of what I was talking about. So we're now starting to get more towards the fall time, because look at the angle of the sunlight is starting to go down and down. That means the sun is starting to fall further down in the sky. So if you just keep watching this, push. Okay, so now we're in autumn. Look at how angled the sunlight is hitting, and it's going low in the sky over autumn. So that's the reason for the seasons. I hope you kind of understand it a little bit better. There's autumn still. We're about ready to turn into winter. So there's the winter solstice. Look how low in the sky the winter sun is. And that's when we are tilted completely away. Here we are up here, tilted completely away from the sun. Look at the angle of the sun's light. Okay, now let's compare that really quick to the summer. All right, so we are going to hit the summer solstice. We're right here. Look at how we're already tilted towards the sun right here. Summer solstice, so look at the angle. So it's almost straight up and down like that flashlight we just looked at. Okay, and the sun is going really high in the sky, and it's really hot because we're getting a lot of light intensity. All right, so I hope that made sense. We're going to continue to work on this if it didn't, so don't freak out. And yeah, thank you very much.